All right, let's talk about monomials in this video. First, we'll walk through what monomials are, and then we'll show you the calculator real quick. So first, monomial is just a polynomial which has only one term. And constants and variables and monomials are monomials as well as one-term polynomials. Now I want to walk through a few examples. So in this column, I have an expression. In this column, it's yes or no, whether it's a monomial or not. And then the last column is reasons. So because 6 is a constant, yes, it's a monomial. X is a variable. It is also a monomial. 5x squared is the typical monomial we see in math. So we have a constant with one variable and an exponent. 5x squared plus 3, however, is not, because we have two terms. And the monomial definition states it must be a one-term expression. 6 to the x is not a monomial because the variable is an exponent. Exponents must be integers. 3y over 2 is a monomial because 3 over 2 is 1.5y. And so you have your one-term expression there. Finally, 5x to the 2/3 is not because the exponent is not an integer. So this grid lays out for you various examples of what is and what isn't a monomial. Next, we go to the rules. So first, we have a multiplication rule. X to the m times x to the n is just x to the m plus n. X to the m divided by x to the n is x to the m minus n. And I will show you a few more rules here coming up, but I will switch screens. And now we will go to the Monomial Calculator. I'm going to put a link to this calculator in the video so you can switch your terms and explore the different calculations. First, I want to cover two more rules though. First is the addition rule. So if you have x to a variable and the variables match, you can add m and n. And the same thing, if the variables and exponents match, you can subtract the constants if you're subtracting the individual terms. Now I'll run through three of these problems. So first we want to raise a monomial to a power. We'll do this. 6xy cubed raised to the fourth. Using our rules that we covered on the PowerPoint, we've got 6 to the fourth is 1296. Next we'll take x to the fourth. X is just x to the 1, so 1 times 4 is x to the fourth. And finally, we've got y cubed raised to the fourth, and the rule is you multiply the two exponents. So 3 times 4 is 12. We piece together 1, 2, and 3 to get our final expression. 1296 x to the fourth, y to the 12th. What if we want to multiply two monomials? So we'll go ahead and hit multiply. First, we've got to do this rule here where we expand. So we expand that term out. We get 243 y to the 20th. And now we want to multiply it by this. So if we do that, we have this expression. We can multiply the constants. And then these two will just add. So y to the 20th plus 3 is 23. We group together those three pieces. We get 1944 x to the 6th, y to the 23rd. Finally, we want to divide monomials. So we'll divide one by the other. And the rule is matching exponents or matching variables, subtract if you're going from top to bottom. So first, we got to expand this piece, the top. And when we do that, we get piece 1, piece 2, piece 3, piece 4, piece 5. Expand that out, we get this term. So now we're going to divide that by this denominator here. And this is where the subtraction happens. So first, if we simplify the constants, we get 19683. If you divide this by this, you get 19683. Now we want to simplify the variables. Because a is by itself and there's nothing at the top, that stays the same. W is by itself on the top, that stays the same. But x has one on the top and one on the bottom. The rule is we subtract. So x to the 10th up here minus x to the 6th on the denominator is x to the 4th. We want to do the same for y. Y to the 20th minus 3 is y to the 17th. And z we're going to subtract as well because it's 7 on the top, as you can see here, or 7 on the bottom. 5 on the top. So we're going to subtract, but the z squared goes on the bottom because the winning exponent, the greater exponent, started in the denominator. So when we simplify this term on the left, we get this term on the right. And that is it. Thank you for watching.